So that we go. Hello, welcome to the California Music and Innovation Summit 2021. First of all, thank you so much and thank you for your patience. There's no conference without technical issues. We have ours and I hope it will be the only one. So I am Jérôme Van Erf. I am the director of California Music Tech. And for those next 4 days, I will be your host with my friend Sudha Ketrapal. Hi Sudha, how are you doing?
Hi Jerome, I'm good, thanks. I'm live from London, so it's all tech. All tech this morning, so live from the London's Rattle Studios. It's great to be here and co-hosting alongside Jerome.
Thank you so much, Sudha. I'm so happy to have you with me this year. I'm based in Liège, Belgium. So we are in Europe. Maybe before beginning the session, very shortly, a few words about California. What is California? California is an entertainment tech hub, as I said, based in Liège, Belgium. And our objective is to connect the dots between the innovation, the startup, and the music industry. By doing what? We have 3 pillars. We have the investing pillars, so by gathering investors from all over the world to propose them some awesome startup, music tech startup, by connecting those guys, so the whole ecosystem, by organizing this kind of summit. And normally it's organized physically in Belgium. And this year, and as last year, it's unfortunately online, but we are very happy to gather all of you this way. And finally, the third pillar is venturing by organizing acceleration programs. And we have organized the last 10 weeks our 5th acceleration program with 15 startups from all over the world. And the demo day will be organized this Thursday. So again, welcome. Today it's the AI and Creation Day, but before giving the mic to our first speaker, Sudha will give you a little bit more information about those next few days.
Thank you, Jerome. Yeah, we've got an exciting, action-packed 4 days planned ahead. Each of the days has a different theme. So day 1, as Jerome has said, we've got AI and creation. And this is in partnership with the AI Song Contest, which is super exciting. We've got fans and content for day 2. Day 3 is data, insights and analytics. And day 4 is smart venues. And kicking off this year's California, we are very privileged to have our first keynote speaker. The originally planned keynote was by Dr. Rebecca Feebrank. Unfortunately, she's been taken ill. So we're very lucky to have Anna Huang. Anna will be talking about interactive generative models from music. Anna, the floor is yours.
Thank you for the kind introduction. In creativity, we welcome glitches. So today we're definitely witnessing a lot of surprise and glitches. Today, I'm going to start by giving a slightly different talk. It's not yet focused on creative practice, but instead focused more on enabling novices to participate in music composition. So the title of my talk today is Interactive Generative Models for Music. I'm a research scientist on the Magenta project. I'm also an organizer for the AI Song Contest. So I'm really excited everybody's here. We're all looking forward to the award ceremony. But before we get there, we have a series of talks and panels and music performances prepared for you. So hang in there, and we'll go on to the next slide. Can we turn listeners into creators? So a lot of us love listening to music. Novices have their favorites. Can interactive generative models provide opportunity for them to try out the fun of creating something musically. So I'm part of a group called Magenta at Google, and as part of the group, we're primarily based on focusing on research, exploring the role of machine learning as a tool in the creative process. There's two components to our research. One is the machine learning component, focusing a lot on algorithms for generating different kinds of media. And then there's HCI research that thinks about human-computer interaction. How can we turn these models actually into tools and interfaces that can be useful for novices and musicians when they want to create something? So this switches the question around from machine learning to human-computer interaction. On the machine learning side, we're trying to model a lot of media and get realistic generation. But when we want to use these models as tools, we actually need to support a different set of objectives. Humans actually have to enjoy using these tools to create their own content. So for example, instead of AI creating music, art, writing, or dance, we want human creators to be able to use AI to create all these kinds of content. So this requires going from machine learning objectives, expanding that, and including human objectives. For example, thinking about user control, thinking about creative agency, and the sense of authorship. So be able to connect these two components, it requires new research on the intersection of machine learning and HCI, and also music cognition, so that there can be new ways for humans to steer these generative models, and also to support users in a creative workflow. So today I'm going to talk about mainly three components. First, I'll start with how can we design ML for interaction? And then I'm going to talk about some of the challenges of scaling up these generative models. And then how we might support and learn from the creative process itself as future work. And if we have time, I'll go into a bonus track from the AI Song Contest last year. So how can we support AI in the loop kinds of interaction, where the novice gets to actually interact with the AI in an iteration process, not just I'm continuing what you have, but I can go back and edit. So this involves a different low-level API. And if we think of this as infilling, as kind of this general approach of iteration, then naturally it supports a wide range of tasks. For example, you can generate from scratch, you can have some material, the AI can condition on that to generate the rest. It can help you generate transitions or fill in the gaps that you have so far. So here I'll walk you through a project where we had to innovate both on the HCI side and also the machine learning side. On the machine learning side, it was coming up with a new way to do infilling as kind of a low-level API. And on the user side, being able to support human in the loop, we used this model as a building block for creating a doodle that I'll talk about right after this. And after the doodle experience, we realized, oh, there's actually a lot more AI steering tools that are necessary. We actually need a much higher level API for human and AI to co-create successfully. So I'll start with this first application of the doodle. This was launched about 2 years ago. And I'll play a video to walk you through that experience.
All right, let's start with an E. E to G. Back to E. To D. C. And B. This sounds great. Now let's click the harmonize button. It doesn't sound too bad, right? It sounds pretty awesome. But now, how does it sound if we play these 4 voices on a guitar? On 4 guitars. Let's find out. That is pretty cool.
So this was a doodle where the people around the world got to interact with a machine learning model to have a try at kind of writing counterpoint that a lot of first-year music composition students do as a first step to composing music. And in 2 days, we had users contribute 55 million of these melodies, and the model harmonized them. And during peak hours, and more people were composing with the doodle than listening to music. So this really shows that with some machine learning model and generative abilities as a tool, it really allows more people to try out composing music when they otherwise wouldn't have thought possible. Even though a lot of people played with this tool, we found there were a lot of challenges in terms of users feeling that they had the control. For example, some users said it felt like the machine was doing all the work. Even though I was able to put in the melody, a lot of the other parts the machine generated, it felt like the machine was the brilliant composer. And they felt it was a bit of a take it or leave it situation, because the harmonization might turn out well. If it didn't turn out well, there wasn't a chance to go in and edit. So this inspired us to go a step further and try to think about what are the ways we could have steered this model so that users could feel more agency. And some of the challenges that people articulated was that they felt like they couldn't decompose the generation into meaningful units. For example, they wanted to generate one part at a time or bar by bar, but the tool gave them everything at once. The next part was they felt they couldn't steer the AI. It was like they were throwing a dice. Everything was happening by chance, but they had specific intentions that they wanted to express. For example, they wanted the music here to build, or they wanted the music to end in a cheerful way. And it was hard for the users to steer the AI. So we built a layer of steering tools on top of this generated models. For example, users can select a particular part, and they have controls to say, I want this part to sound more adventurous, or I want this part to sound darker or more similar. Here, I'll show you a quick video of that iteration process with these new controls. It's the same interaction initially as the doodle. I suspect the video might be looping. So we saw it a couple of times. So now we're all familiar with the controls that the tool has. So we saw after running a user study that these controls really helped user feel a sense of collaboration and also control over the creative process. So next I'm gonna go under the hood and look at the model that's actually supporting these interactions. So this model is a general infilling model. So you can have any parts of the score missing and it will help you glue it together. And the way we represent music in this particular case is looking at it as images, where the piano roll is pixels. So for example, the RGB channels of an image model becomes the soprano, alto, tenor, bass, the different instruments of the music. And traditionally, when we model music or sequential data like text, we have to assume there's a particular ordering. For example, we're generating from the beginning to end, or maybe we can generate backwards. So we know how to end and then we generate from backwards to the front. But actually, there's many different permutations possible. And in particular for music, we have harmony, we have melody. A lot of times we're forced to choose, for example, in music analysis, which one to prioritize. But if we're able to model all orderings at the same time, then it can account for all of these interdependencies. And in that way, we actually get a very general model. And we can train it in a way by doing the data augmentation on the score by blanking out different parts. And we can cover all the cases that during test time we might encounter, and then get the model to do the reconstruction. So for a few minutes, I'll dive a little bit deeper on why this masking out and reconstruction can actually help us model all those different dependencies and orderings. And this is because here we have this toy example. The first note is seen. It's already put in down. And when it does reconstruction, it's predicting what is the relationship between the first note and the second note, and also the first note and the third note. And that gives some of the components that are needed when we want to generate in these different orders. So in here in particular, we're getting components for generating 2 orders. So if we try out all permutations of masking out the score, then we have all the components that we would ever need during test time. For example, here I'm picking a particular ordering of 1, 3, 2, and you can get these components from these different blank out schemes. So in terms of generation, we actually not just follow one ordering and generate according to that, because that wouldn't be able to take care of all the dependencies. Instead, we do this rewriting process, kind of inspired by how when composers write music or novices, we often go back and edit and rewrite. So this model also does something very of that manner. So next, I'll show you a video of this rewriting process. So this would be what the model does when it's generating. Okay, I think that video might not be available. So we'll jump on to showing you a musical example of why this rewriting process can be helpful. So before the doodle, a friend of mine really wanted to write a melody. So this is what he sent me. So he wanted the model to harmonize this. It's a little soft, so I hope you heard the ending, because the ending is there was a tweak there. Initially, I thought this was a joke, but once I heard the ending, I knew it was a hard question, because if models were usually generating from left to right, then once they get there, it would already be too late for them to anticipate the change. But because this model does a back and forth, up and down rewriting, it's able to kind of propagate that change into more of the beginning and be able to prepare that. So next, we'll hear the harmonization from the model. Thank you. So now we'll move on to the next section in the talk, which is about how to scale up generative models to model more complex music. So what we've been looking at so far is very structured 4-part back chorales. If we wanted to scale up to music that is not on a grid and has a much more simultaneous events happening at the same time, how do we do that? So the next model I'm going to talk about is Music Transformer. And it not only models the notes, but it also models the performance, so the interpretation of the performer in terms of expressive timing and dynamics. And it also tries to get more of the structure in terms of like AA, BA, and themes returning. So why we wanted to not just model the notes, but also the performance is because here I wanted to show you a visualization just to show the contrast. The top one is if we just visualizing the music as this from the score, and the bottom is visualizing a performance. And right away you see the colors. That's showing like the dynamics that the performer is adding is quite a wide range. So that's the kind of data that we are modeling. So in order to do this, we use a representation that also accounts for not only the notes we're playing and also how loud we're playing the note. And then in terms of how we advance time, it has very fine-grained resolution to account for micro timing. So before that, the go-to method for modeling musical sequences and long sequences in general is to use recurrent neural networks. But recurrent neural networks has the challenge of not really being able to remember for a longer period of time. So I'll demonstrate first how some of the failure modes that we'll hear. So here the experiment is that we'll give the model a beginning motif. So that's a really short but iconic motif you might recognize. So we're priming the model with that. And what you hear next is the continuation. So you see it's sounding piano-like, and a lot of the moments are very kind of virtuosic and idiomatic, but it's chaining together many different fragments. So let's see how a transformer model does. So a transformer model is the self-attention models that's able to keep everything in memory, and whenever it's generating forward, it can look back to see what's relevant. So in the next slide, we'll hear what the transformer does. So initially, the transformer does really well. It's really taking the motif and carrying it forward. But as soon as it goes into kind of a longer sequence that's beyond what it's trained on, it deteriorates very quickly. So what we needed to do in order to get the model to focus more on relational features is we created different kind of ways to do self-attention, and that the result is Music Transformer. So we'll hear a sample from that model. So right away you hear it's able to kind of carry that motif through a chord progression and sustain that coherence. So in this experiment, we were priming it with kind of iconic snippets. So next, we'll see a sample that's generated unconditionally. So this is letting the model kind of dream up its kind of imagination. So maybe we'll fast forward on these slides. These parts are trying to explain that self-attention allows you to really look back. And in some ways, it's similar to convolutions in terms of the new algorithm contribution that we had in this paper. And that allows us to scale up really to longer sequences because initially the memory usage was very high. So with that memory optimization, we were able to generate longer, more coherent sequences. And this is a sample that you see. Here I'm going to highlight the parts where the theme repeats. So you might see some grayed out area. I think it's very faint. But next we'll see the self-attention. So we looked into the box to try to understand why these models are actually able to generate so much structure. And then when we looked at the last layer, this is the kind of structure that we see. So each of these colorful arcs is some of the attention mechanism looking back at parts that I think is relevant to inform its generation. So let's hear actually the music being played back at the same time so you can hear more of the structure. So music has multiple levels of structure. We were modeling more of the symbolic parts of the music. And one of the questions that was being asked is, can we actually learn a lot of the nuances in performance from audio? So colleagues and I built this kind of factorized approach to go from audio to MIDI. And then build kind of synthesizer-like models to go from the MIDI to audio. So this allowed us to transcribe a lot of MIDI and train on that symbolic data using the music transformer architecture. So this model is called wave to MIDI to wave. So the next sample that you hear is exactly the process that I just described. The model is trained on transcribed music, and then it generated a new sample, and then the synthesizer model that we built synthesized the sample. So in some ways, it's all components are from neural networks. So there, you heard the model making a couple of pretty wild turns. So later on in my talk, I'm going to talk about how can we actually enable users to steer some of these turns so it feels like a more directed process. So in the next part of my talk, I'm going to talk about some future work where we want to really support the creative process and design interactions where we can learn from that process to provide better exploration support to the user. So a little bit about the creative process. Creative process is very complex and very personal, but a lot of times we think of it as consisting of two stages. There's the divergent stage where we try to flesh out a lot of ideas and brainstorm, and then the convergent stage where we try to kind of narrow down what we want and refine and iterate. And a lot of times people describe this process as like a Christmas tree because we go through this cycle multiple times. And so in terms of supporting this creative process, each of these two parts actually has very different kinds of behavior that we want to support. For example, in the brainstorming part, you might be doing a lot of branching. So how do you support that kind of exploration? On the converging side, you might be prototyping and try to iterate and zoom in, and that's also very different kind of process. So here I'm going to focus on the branching process a little bit more and see and show a demo of, can we explicitly kind of support this branching and exploration process? And in particular, can this be a process that actually allows novices to come explore and steer the generation according to their own preferences? So in this case, they can kind of curate chunk by chunk. So they're listening, but as they're curating, they're also kind of creating their own trajectory. The metaphor here in terms of the interface is where we have this forest with kind of different paths that you can explore sonically. And the idea is we really want to enable people to steer things, their experience their way. So here I'll show you a quick demo of that. So initially, we're going to explore all the parents of the trees and hear how they sound like, and then decide if we want to go in and explore more. I decided to listen to that a little bit more. But after that, I still wanted to explore the other ones. Okay, this is the last one. So let's see what's possible here. So I'm going to sample a path through it first. Oh, I think we looped to the beginning. Okay. Is it possible to give that another try to see if we can fast forward a bit to the middle and hear the rest? Thank you. So I believe that is a path sampled into that tree. So I felt like I could make it more interesting. So now I'm going to curate chunk by chunk. I really like that turn. So I'm going to choose that and explore the continuations from there. So I like that one. Here I'm going to try out a couple. Okay, I was really happy I actually found an ending. So here we'll hear this curated version. Voila. So that was thinking a lot about how to support novices. So for the last little bit of my talk, I'm going to end with a bonus track from last year. Yeah, let's go forward. So this is also kind of an interface that we're thinking about to kind of support exploration and allowing kind of, for example, reinforcement learning algorithms to learn from how you're making the choices and help you explore parts of the tree that's more relevant for you. So we also want to allow people to, for example, specify the musical tension and be able to navigate that way. So for the final part, that brings us to last year's AI Song Contest. That was the first year, and we had 13 teams participate. We saw teams face a lot of challenges in steering these models. As you can see today, that the models are pretty rigid, and we're just in the beginning of trying to find ways to enable more interaction. In particular, for example, because the artists wanted more control over the models, a lot of times they would use kind of smaller models that they can steer better. So they would have separate models for lyrics, separate models for melody. And then the models are not aware of the musical context of the other one. So for example, you have lots of melodies and lots of lyrics. Like, how do you fit them together? So Team Uncanny Valley, who won the contest last year, came up with a really clever way to match these up using the stress patterns of lyrics and melody. So this allowed them to go through the generated material a lot faster and find ones that are more directly useful. So next, I'm going to show you some of the raw synthesis of these examples.
Sophie is beautiful, the world.
And then so you heard some raw examples, and then maybe let's go back and listen to how that sounded in the final track.
Sophie is beautiful, the world.
Thank you for the showcase and the fade in. So you see, when artists start using these models, it becomes a lot more interesting. And this brings me to the end of this talk. So we're looking forward to this year's AI Song Contest and the award ceremony. I'm very excited to see that this year a lot of teams are very intentional about their use of these models and really having a very strong creative vision. At the same time, also exploring a lot and embracing a lot of risk to discover new possibilities. So thank you for tuning in. These are some of my collaborators on the projects, and thank you for listening.
Thank you so much, Anna. That was super insightful and fascinating. It's made me want to turn around and start creating myself. We've been collating some questions on the chat, and there's one here that we'd like to ask you. So this is from Gordon Stanislaw. Why would you want to turn listeners into creators? What's the rationale behind that?
That's a really good question. In some ways, it's a very simple one. Wanting to kind of allow more people to express their kind of the kinds of musical trajectories that they're interested in. And I think a lot of people have very strong kind of musical taste and preferences, and having ways for them to kind of express them through these tools, I think could open up a lot of possibilities.
Thanks so much. Fantastic. Once again, fantastic keynotes, and thanks for stepping in as well. Okay, so the plan next then is to meet at 1 p.m. CET. That's 1 p.m. CET for our next session. which will be with Sophie Goosens. Thanks so much. See you then.